start? Okay. So, hi everybody. First of all, you can always interrupt me. No problem with that. I have a very chaotic presentation style, so you cannot make it worse. My name is Romeo Kinsler. I work for the IBM Cloud Transformation Lab in Zurich as a chief data scientist and also as a cloud architect. And today I will show you how to implement microservices in a scalable fashion, how to run a DevOps part on it. And we are using mostly open source technologies, but we will use the IBM Cloud. But you will see the IBM Cloud is open by design, so we won't have any vendor login in this cloud. So yeah, 3 to 4 slides about the IBM Cloud itself, because a lot of people, they don't know that IBM has a cloud. So I state this, and we are about the second largest cloud vendor on Earth. So we have a lot of customers worldwide. We have nearly 50 data centers worldwide. The nearest from you is in Frankfurt. There's one in Switzerland, in Paris, Amsterdam, London, and Milan, and everywhere you can imagine. We are not that expensive, so in this list we are the third cheapest vendor here if you take normal virtual machines. And price itself is not a reason to go to the cloud, because you see here, this is a report which states that it's about scalability and time to market and availability. So if you have a correct architecture in place, a cloud is always more stable and available than a single data center. And now we have some pizza. So maybe you have seen this slide before. Who knows this pizza as a service? Ever seen before? Okay, so I just want you to illustrate the difference between on-premise infrastructure as a service, platform as a service, and software as a service. And like making pizza, if you do everything at home, you have the greatest amount of flexibility, but then you have to really do everything at home. And if you are dining out, then you have to do nothing. You pay more, but it comes as it is. So you have a little choice on the customization. And the same holds for clouds. So if you do on-premise, I think a lot of people just stop to do on-premise, especially in the startup scene. So what I see in the startup scene, most of people do infrastructure as a service, and also combine it sometimes with software as a service. So they call some APIs, or just use another solution like Salesforce.com or something like that. And what I will show you today is in this area, the platform as a service. So the basic idea is that you just bring your data, you bring your source code, your application, and all the rest is managed by the cloud provider. The IBM Cloud is open by design. That means on the infrastructure side, we stick to the OpenStack standard. And on the platform side, we stick to the Cloud Foundry standard, which is an invention by Pivotal, which is a daughter company of VMware, which is a daughter company of EMC. And now there is a huge consortium around this standard where IBM takes part, but also a lot of major vendors. And it's an open standard, and also the implementation of it is open source. All is written in Go, in the Go language, and the same holds for Docker. So we have also Docker Cloud, and it's also written in Go, and all is available in this cloud system. And the cool thing about Cloud Foundry is that on the runtime side, you're completely free. So the runtimes are plugins, and these plugins are hosted on GitHub, so you can just get them from there. While you deploy the application, the plugin is downloaded from GitHub, and if you want to modify the plugin, you fork it, you change it, and you can also rebase it. And on the services side, this is completely managed by the cloud system. So you have different kinds of services like databases, SQL and NoSQL, and big data systems like Hadoop and Apache Spark. In the IBM case, you have the IBM Watson services and message queues and whatever you can imagine. And in addition to that, you have also services to connect the local data center with the cloud and synchronize data with it. I just show you the catalog. So the whole idea about this is it's like an app store for services. And there are not only IBM services, like you see here. If we have time at the end of the talk, I show you some 2 or 3 Watson services examples, which are quite funny. So we have, for example, image recognition service, which tells me who is on the picture. For example, I can upload an image or send an image of Obama to the service, and he will tell me he's president, he's black, he's male, he's about 50 years old. So I can show you that later if you're interested. There are mobile services and data integration services, databases, whatever you can imagine. And it's an open system, so third-party vendors can actually bring their service to this marketplace. In addition to that, there's the DevOps services to orchestrate all this. And this is based on the Jenkins build server. And we integrate with a lot of open source and startup services. And we have plugins for Eclipse and IntelliJ. There's Eclipse Orion on the cloud. And if I say we have, it's Cloud Foundry. So it's open source, and there are open source plugins for these tools. So this brings me to the reference architecture picture. So that's something IBM made up, but I think it's a valid architecture for doing microservices in the cloud. So what you have here is a web browser or a REST service consumer. Then you enter basically the platform cloud. There is a load balancer. This load balancer is also coming from Cloud Foundry. And then you have a scalable runtime. And in this case, we have out-of-the-box support from IBM for Node.js and JEE. But as I already said, you can plug there anything you like from Python, PHP, Go, R, Scala, whatever you like. So in addition to the runtime, you have the delivery pipeline, which actually can deploy new applications, for example, based on a check-in on a Git repository, a build is started, the unit test is started, then it's automatically installed in an integration environment, and integration tests are running, and you can drive this up to continuous delivery, like Facebook, Google, and so on are doing. They have multiple productive deployments per day, and if they face any issues, they fix it. This is called fix forward. And what you also can do is zero downtime deployments, deployments. That means you have a productive application running. You install the second one in the production system. Then you register the new application in the load balancer, and you get a round-robin schema. So you will once see the old and once see the new application. And if you are happy, then you can delete the old entry, and all the requests then go to the new application. And this happens at zero downtime. And later in the demo, we will see that it actually works. So we always get response code 200, HTTP response code 200, and no errors. So this was the runtime, and this is also continuously monitored. That means you can monitor response time, throughput, memory usage, CPU usage, and based on policies, you can scale up and down automatically. In addition to the runtime, which can connect to database services, and of course they have to be scalable as well. So I have here an example of Apache CouchDB as a service, which is a scalable NoSQL database. And in contrast to MongoDB, it's not a master-slave architecture, it's a ring architecture. So it's very well suited for continuous scale up and scale down. And of course, you can use traditional databases. So there are different databases like DB2, MySQL, PostgreSQL, which also are cluster enabled and also do continuous backups. So that's all coming as a service. And I can actually provision such a database in less than 10 seconds, and I can show this later as well. And there are some Microservices, for example, for session caching, because if you scale up and down these containers, then they are also fault-tolerant, and if one container fails, the session is replicated to a persistent in-memory service, and therefore you can just start a new container, and the session is then replicated back to the application runtime, and some other important services like single sign-on and so on. Yeah.
The previous time there is a text return. Is that like, does that signify anything, or you just forgot to remove?
Excuse me?
About the load balancer.
Yeah.
Text EXT.
That's error in my presentation, sorry. So important to know is there's a free tier, so you can do it at home, or you can do it in the cloud. You can do it in the train from your mobile if you like, and it's quite sophisticated. So if, we have Apache Spark, with Hadoop, and a lot of storage. You can have virtual machines. You can have use the Docker cloud. It's all for free. We have some startups in Germany. They use it completely for free. They are using this for their production system. They are also using Watson services for free because there are some 1,000 calls per day for free, and they just ensure that they don't do more. We have a startup program. Any startups in here? Yeah, okay. So you can just join. You get up to $120,000 for free credits if you use the cloud. We can talk about that later. And for students and faculties, get also a free program. And if you don't like us anymore, you can just go to another vendor because we are based on standards. Okay, so that's the thing I wanted to tell you, and now I will switch to the demo. So what I will do now is I will show you how to implement the REST service on top of Node.js. And since we are all lazy, I will use a framework which IBM has built, which is called Node-RED. And this, of course, is also open source. That allows you basically to draw your application. And this is really fast. I've prepared this already, but I will just do it from scratch now, because I have time like until 7:50 or something. Yeah, okay, so then I think there's plenty of time for doing that. So what I just do now is I will implement a REST service. So just a simple HTTP endpoint. And I will call it BW as backend web. And then I hit deploy. And I did maybe something wrong. I just double check. Excuse me?
You press cancel.
I pressed cancel?
Yeah.
Oh, I'm so stupid. Thanks a lot. Okay, so... Okay. I just have to wait until you see this successfully deployed message, and then this application is already deployed. And you can call it now. So what I will do now is I will open a new tab, and I will call the backend web REST service, and you see just it's like an echoing service. If you pass a key like we are hiring, and this is return. And now I want to modify this thing. So what I will do is go back here. I will insert a function, and since this all is running on top of Node.js, I can add simple JavaScript functions in there. So I say whatever comes here. So this is all the data between the node is transferred as JSON, and therefore you can just out of the box use the OGNL notation in JavaScript to access the fields. And everything which comes in on the service is stored in the payload object. And since I'm passing a key parameter, I can access this value with the key. And what I do here is I just use the value which is sent to me, and I add an additional character. Let's see if this works. So I redeploy, and I reload here. You see here, can you see that? Okay. Otherwise you have to believe me, there's an additional character now. And now I also want to debug this. So I want to see what actually is sent back to the browser or to the caller. So I just add a debug node, and I recall the endpoint, and then I should see some. You see, I've already tested this before, so it works. And now I want to log all the REST calls to a NoSQL database. So what I do now here is I use a connector. So there are some built-in connectors which we have already built for MongoDB, CouchDB, HDFS, Hadoop, IBM DB2, but you can easily extend these connectors through pure JavaScript. So I will use the Cloudend connector because our CouchDB as a service is called IBM Cloudend. And I just select the service name, and then I select the database. I also say BW, operational insert, and I say OK, and I hit deploy, and I do a reload of this, and now I expect to have an entry in this CouchDB. So what I do now here is, you see here there's one entry in this BW table, and it's a JSON document, and it reflects the JSON structure I'm storing, which is key on this one here, including the additional character which I've added before. And now on top of this, I want to deploy an application actually using this service. So I have prepared this already. It's a little AngularJS application. Anybody here familiar with AngularJS? It's the successor of the Google Web Toolkit, and it's quite handy. So I've prepared this. So the only thing I have to change, I think, is the endpoint name, which is BW. And what it does, it just displays a text area and sends the content of the text area to the REST endpoint, and it returns the response. Go back to my Node Web instance, and I actually will create a second HTTP flow. So I have to start with the HTTP node here, and I will choose template, which actually can be used to inject additional parameters into the HTML. But I won't do this here. I just paste the dummy HTML code here. I connect this one, and of course I have to respond back to the client. So I add the HTTP response, and I redeploy. Oh no, what I have to do is I have to select the endpoint name. It's BW app, for example. I say OK. I say deploy. And now we should see the application. So, okay, what I do now is I will add something which tells me later on which container instance I'm running, because I want to show you auto scaling, and of course the same application will run in different containers. And in order to know where this container is running, I can read out the container ID as the operating system environment variable. And I will just use my already running application as a cheat sheet. And I will paste some additional stuff. Let's paste everything, because then I'm 100% sure that it works. But I will just walk you through the code. So, as already mentioned, that's pure JavaScript code. So again, I will just modify the parameter. Then I will set as part of the payload instance ID, which I read out of the context, and the context gives me access to the operating system environment variable. And that CF instance index is environment variable which Cloud Foundry itself injects in the container, so I can read it there. I have also to specify a header for the response that I'm sending back JSON. And then what I do later here is I will generate some load on the system, and I will just populate some data into the heap. Into the stack of this application, and I can parameterize how big this is, because I'm passing the iterations parameter into it. So that's used later for the scale test, because you somehow have to generate load on it. So I hit OK, and I hit deploy, and now I will just check if this works. Okay, you see here test and my two additional characters and a 0. And 0 means that's the container ID, because at the moment there's only one instance running of this runtime, and we will see later how the round-robin scheme of the load balancer will just return different container IDs. So I think I'm done here with my application. That's pretty fine. And what I do now is I will put some load of it, but before I do that, I will just briefly walk you through the command line interface of Cloud Foundry. And I'm sure I have increased the font size. So that's.
Where are you hosting the AngularJS application?
Excuse me?
Where are you hosting the AngularJS application?
That's as part of the Node-RED/Node.js application. So I just go back to my Node-RED instance. And you see here there's a second HTTP flow. And if I double click on this template node, then you see the HTML. That's the AngularJS application.
Okay.
And it's basically, it displays this text field, a button, and there's a controller which just calls, I'll just show it to you here.
This AngularJS is just adding a script tag over there.
Exactly, yeah. So and here's the controller which then does the REST call here and updates basically the DOM. So now I show you. Basically, there are three entry points into a Cloud Foundry Cloud. No, there are two. No, there are three. One is via plugins of the IDE. One is via a REST API, or one is via the command line tool. And IBM provided the fourth one. That's the web interface, which I will show you later if there's time. So you can do a CFA, and if you do CFA, it will show me all the applications currently running in my space. That's here, for example, this Node-RED application, and I can scale it from here. So I could say scale to 2 or 3 instances, but I want to use auto-scaling. So what I do now here is I will generate some load. And I will just press this endpoint a bit. So I have to use the other one, which I've just created, PW. And I say, okay. So you see now here that you always get HTTP code 200. So at the moment there's no error. And if I hit Ctrl C, you see that the buffer has to empty. And when the buffer is empty, I get my prompt back. Okay, let's wait until it's empty. No worries. Okay, so I'm actually wondering why this guy is not dying. Die. 1 second. Okay, so bye. So, and it shows you here the availability, and we always expect that it's 100%. You get also the transaction rate, which is 13 transactions per second, so 13 HTTP requests per second. Now I can go to my cloud system. You are, for the first time, I think, seeing now this web interface IBM provides, and if you go to the dashboard, you see here that is my application, and this one is the auto-scaling extension, and here I can configure different policies. So I've configured a policy for main memory usage, and I will show you how this looks like. So of course I have to enable this policy, and I just edit it, that you see how it looks like. So it's memory, and if I'm above 40%, then it will scale, and that's a bit artificial 40%, but I'm sure it works with that number for this use case here. And I get statistics, and you see here That's the main memory usage of my application, and it will scale once this is enabled. So I will put back load again here. And then I've configured the threshold to 30 seconds. So if you have more than 30 seconds, this amount of main memory usage, it will scale an additional instance. And we will soon see this here. So while we are waiting, are there any questions so far? Yeah, so we provide it from Bluemix as a service, but we have also open sourced it. So if you go to Node-RED, I think it's node-red.org, you see, it's open source. And it's an application running on top of Node.js. So it has all the advantages of Node.js, and it's very easy to use. So let's see if that still works. So we still get code 200, and we should see auto scaling action soon. So it already happened. Here it's 7:33 p.m. and it says the memory usage exceeds 40%, and then a second instance is added. And now we should see, if we call the endpoint, that it switches between, you see here, that's instance 0. Just to, it does round robin, but it's, you see now it's 1. It does round robin between these requests here, which are 15 per second, and these requests, so the chances are high that I just hit multiple times the same window and land on the same instance. So what I can do now here is, if I like, I can add a session cache to the application, and then this router, which I've shown you in my presentation, which is there, this load balancer here. I call it router because it's a router on the HTTP layer. It reads the host field in the HTTP header in order to route the request to the appropriate container. This one uses a round robin scheme, so that's actually the load balancer. And I think I've configured up to 3 instances, so you will most likely see them 3 instances. I think you saw a 2 here. Just repeat a bit. I've already seen. Yeah, I have to prove because I'm recording this session, so in case it doesn't happen again. Yeah, whatever. But there are actually 3 instances running, I assume. I can also check it via the web interface, the command line tool now. I can say cf scale node-red RE, and it shows me how many instances are running. No, still 2. Okay, so maybe I have to buy classes.
Start new tab and then maybe to start third instance.
Excuse me?
Start the same session in new tab, so maybe to start the third session.
Okay, what I can do, I can also increase the load here. I have to kill it again, and I can increase the load, and then it will add another session. And it also will scale down. If I just stop this or kill this, then eventually in 1 minute it will come down to 1 instance only. Okay, any questions so far? So I don't really understand your question.
So suppose I have a memory intensive application,
Yeah.
and if I take the same node with the same, so I don't want to see 20% of RAM usage.
Okay.
But other services don't say
Okay. That you don't care in the platform cloud, because there is a system called containerization. So that actually allows you to have a virtual, something like, behaves like a virtual machine, but it's not a virtual machine, it's a process group. And that actually allows you to define a maximum amount of memory which you can consume in that process group, and the system is based on this. Have you heard about Docker? So it's the same kernel extensions which are used for Docker are used here, but the technology is called Warden. And this way you can define this, because if you see here, memory 212 megabytes. This application is running in a container, and the container is configured to not allow you more than 212 megabytes. And by the way, you are charged on the memory consumption only in the IBM cloud, and 502 megabytes are for free. So you can use one JEE server, or like 4 to 8 Node.js servers, and 8 to 16 PHP applications. Okay, I think I just used my last 8 minutes to show you the Watson services. So I check. Oh, so these are basic services. It's speech to text, which maybe is the most tricky one, because I'm not using a headset, and therefore the quality of the recording is not so good. But as you can see, most likely in a couple of seconds, based on the context, the system is understanding what I'm saying. And the cool thing is, it shows me metadata. Maybe I should have used not English, but another language, because I'm not a native English speaker. Yeah. And the other thing is the text-to-speech, which basically is better. So, you know IBM Watson, the system who won Jeopardy? So actually we gave the system the voice of the guy. So, hi, I'm here for this cool meetup and want to show off with the IBM Watson services. Or I have to use the word cognitive. Makes it more interesting. So let's speak.
Hi, I'm here for this cool meetup and want to show off with the IBM Watson cognitive services.
We have also German. Any German speakers in here? Yes or no?
Yes.
Okay.
Hallo, so kann ich schnell und einfach eine tolle Mobile-Anwendung entwickeln.
Not too bad, okay. And then the other thing is I can show you the image recognition service. I hope I have the Obama guy still there. Ah, yeah, okay. So he recognizes him as Barack Obama male, and it used to show me his age, but at least he knows it's a person, politician, president, appointed award winner, whatever. There are also services, for example, you send text there and they generate an abstract for you, or there is a service you send emails from a person there and it returns a psychological profile. Actually, I'm working together with a startup here in Berlin. They want to do a dating app with that service. Yeah, a lot of things you can do. So if you have any questions, you can ask me now or later or via email. And I just want to remember you on this cool free tier and startup program. So thanks a lot.
Some questions?
Yeah.
Are we able to deploy this cloud in our own infrastructure?
Yes, that's the only cloud on the planet, I think, which is hybrid. So you can have this public offering. You can have a dedicated for you on IBM cloud servers, but we give you the IP addresses and the server IDs, or you can provide virtual machines and IBM will manage it for you on your premises. but I think as a startup we can't afford it. Other questions? Okay, so thanks a lot.
Thank you very much.